Traditional unit tests check deterministic code paths. LLM-powered features need a different discipline because the same prompt can produce different, though hopefully equally valid, phrasing across runs. Manually testing a prompt against a handful of examples tells you it can work, not that it reliably will across the range of real inputs your feature will actually see, edge cases, adversarial inputs, ambiguous phrasing, the long tail of real user behavior. Evals are the systematic version of this, a defined set of test cases with a way to score Claude's output against expectations, run repeatably. A useful eval set generally includes 4 kinds of cases: representative cases, realistic examples spanning the actual distribution of inputs you expect, not just easy ones; edge cases, ambiguous inputs, boundary conditions, malformed input your code needs to handle gracefully; known answer cases, inputs with a single objectively correct output, useful for automatic grading; and regression cases, specific past failures added once found, so a fix doesn't silently break again later. The same principle as regression tests in traditional software. Exact match or rule-based grading works for structured output. Does the classification match the expected label? Does the extracted JSON match expected fields? Fast, cheap, deterministic, prefer it whenever there's a checkable correct answer. LLM as judge works for open-ended output like a summary or drafted email, where there's no single correct string. A separate Claude call with clear grading criteria scores the output. This scales far better than manual review, but needs its own validation. Spot check the judge's grades against human judgment periodically. And human review remains the gold standard for subjective quality and for calibrating automated grading, not necessarily for every single run. Prompts are part of your application's behavior and should be versioned and tested like code. Store prompts in version control, not scattered across ad hoc strings. Run the eval set against a new prompt version before deploying it, comparing scores against the previous version. A change that improves one case while regressing 3 others is a net loss you want to catch before your users do. And treat model version upgrades the same way. A new model version can shift behavior on your specific prompts even if it's a general improvement overall. Rerun evals rather than assuming newer is strictly better for your exact use case. Evals catch problems before deployment. Monitoring catches problems that only show up at real scale or with real user input. Log inputs, outputs, and key metadata for every production request, respecting data handling obligations for anything sensitive. Track output quality signals over time. Automated grading scores on a sample of live traffic, user feedback signals, and stop reason distribution, since a rising rate of max_tokens truncation is a cheap, concrete signal something's off. And set up alerting on the signals that matter, not just hard errors, since a quietly rising hallucination rate or drifting classification distribution won't throw an exception. Write a 10-case eval set for the triage assistant. Mix clear-cut and ambiguous tickets. Include at least one edge case with unusual phrasing, and grade classification accuracy automatically. Exact match against your expected label after running each case through the real API. To recap, evals systematize prompt testing across representative, edge, known answer, and regression cases, rather than relying on informal spot checks. Grade automatically whenever there's a checkable correct answer. Use LLM as judge for open-ended output, validated periodically against human judgment. Version and regression test prompts like code. Rerun evals before deploying prompt or model version changes. And production monitoring should track quality signals, not just uptime and errors, since quality drift often produces no hard failure.